Hello and welcome to update number 3 of the Zig CLR project. So this is kind of a big milestone. What I've done is I have completed the basics for undefined value use. And next up is the first actual memory safety check, which is going to be to check to make sure that stack pointers can't escape. Okay, so let's take a look at this before we go on. So this is just an explanation of the run1 shell script that I'll be using a lot. It assigns several variables. Script dir here is basically just the current directory. Zig compiler, that is going to be the executable for the git submodule instrumented Zig compiler. So this Zig compiler is capable of reading a .so file as a dynamically linked library, running that as the backend target. And so we need to provide the backend target. In this case, it's going to be libclr.so. Notice the slightly different path here. So this will be built in our current directory using just a normal Zig build command. And then this libdir is a directory that contains dependencies for the actually transpiled code. So our input is just going to be what file we want to analyze. Then what we're going to do is we're going to take the base name, so that's everything before the .zig, and then create an output file, which is just going to have a .air.zig. And we'll take a look at one of those. We're going to do 2 rounds of compilation. The first compilation is going to engage the CLR library using the farout parameter that I described in a previous video. Then we have to set ofmt equals air in order to trigger that as the backend. And then we're going to femit bin as output. And the reason why that's good is because it will allow us to actually output it as a .air.zig instead of just a .air file. That way we can actually easily compile it in the next step without having to mv it and change the name. And then we pass the analyte right here. Our second round, we are going to take this transpiled code, which is going to be at output, and we're going to declare the CLR dependency, and the CLR dependency is going to be whatever is in our lib directory. Okay, having described that, let's move on and do our first example. So this is use before assign. Pretty classical. We set this value to undefined and we attempt to use it. So let's copy the path. And you can see it's doing the first compilation. And then it's going to pretty quickly go over into the second compilation, which will be much faster. And you can see it's reported use of undefined value found in use before assign.main. So that's this function. And it will even give us the line numbers. Line 3, so this is where the use occurs. And then the undefined value was assigned to x in the same function on line 2. So this is a pretty comprehensive explanation of what's going on here. Let's try this one, which is the same as the previous one, except I have an extra line here where I clobber the undefined value and turn it into the value 5. So let's run that. And it's compiling the first round to build the analysis code. And as you can see, there was no error. It successfully ran because this does not have a use of undefined value error. Let's also look at this one, which is where we're going to set the value through a pointer. So let's copy the path here. This is a pretty common pattern that one uses in Zig, so we really want for this to not cause any problems. And as you can see, there was no error reported. So let's take a look at one of the files that got generated. So this is the air.zig file that got generated. And we can see that there are 3 functions. The first one is the main function. And the main jumps into this fn 2011. And our fn 2011 is this one. And here we can see that it tells us the context of file, what line this function exists in, and also the name. So this is the call sets via pointer main. So this is the main function. The first thing that our main jumps into is this transpiled main. And the transpiled main function is just a list of slot.apply. And this is all information that was grabbed from the AIR, the intermediate representation, and put into code that can be analyzed by the setup inside of the CLR library. And the one interesting one to think about is the slot.call. So whenever we have a function call, so in the original function, it's here where we call set value. We, instead of doing an apply, we do a slot.call. And here you can see it's going to call fn3105. In the parent function, that called the set value function. And here you can see that 3105 is call sets pointer dot set value. So this is indeed the representation of the sets value function. And to basically give you an idea of what happens, we pass this arg0 as a slot as a slot object that we're keeping track of. And when we do the store safe, it is capable of recognizing that this is a previous that this is a value from a previous function call, and it then can modify this. And because that is set to the tracked slot 1, we know that later on when we use it, it is set and not undefined. So that's a basic overview of how this system works. The great thing is that the way that this has been designed, it's already ready to be extended to other purposes beyond just undefined tracking. Okay, so if you like what I've done here, please like and subscribe to the channel. And if you really like what I'm doing, I'll have a link to a Buy Me a Coffee below so you can sponsor this. Thank you very much.